So in this lesson, we're going to be looking at how fractions interact with solving algebraic equations. So let's look at some operations with negative and positive fractions first. So remember, when you're adding or subtracting fractions, no matter what the signs are, you always need to have a common denominator. So the first thing we're going to do on this first one is look for the common denominator between 4 and 8. And so when you're looking at the two denominators, 4 is a multiple of 8, so we would multiply the 4 times 2 to make it an 8, and therefore we have to multiply the numerator by 2. 2 times 3 makes 6, 4 times 2 makes 8, and now our problem is this. And what we're really doing is, remember, we're keeping the denominator the same, and we're only adding the numerators. So what we learned from integer operations is that when we're comparing the absolute values, 6 has a greater absolute value. So that means we're going to be taking the difference of 6 and 5, which is 1, and it's going to be positive 1 because we have more positives than negatives because 6 has a greater absolute value. So the sum of 3/4 and negative 5/8 would be 1/8. When dealing with mixed numbers and division or multiplication, we do not use mixed numbers. We always go ahead and convert to an improper fraction. So remember, to do that, we multiply the whole number by the denominator, and we add the numerator. 1 times 5 plus 3 makes 8, and we keep the denominator. When dealing with division, we change division to multiplication, and we reciprocate the divisor. So this will become -2 over 1. And now we go ahead and remember that we multiply numerator times numerator, denominator times denominator. And we follow our integer rules for multiplication, which says when we're multiplying two numbers, if they both have the same sign, we make it a positive. If they have different signs, it stays negative. So negative times negative makes it a positive. 8 times 2 is 16. 5 times 1 is 5. And because our problem originally had a mixed number, we go ahead and we change this to a mixed number by making it 5 goes into 16 3 times. 3 times 5 is 15, leaving us a remainder of 1. And we keep our denominator. And so our quotient is 3 and 1/15. Okay, so there's two methods that we can use to work with fractions when we're solving an algebraic equation. One of them is just deal with the fractions. So we do any adding, subtracting, multiplying, or dividing that comes up with the fractions that are given to us. So for this problem, we need to go ahead and take care of doing the inverse of multiplying by 2/3 and subtracting by 5. So our first inverse operation is to add 5 to both sides. So we have -4 plus 5, which is going to give us a positive 1. And -5 plus 5, which is 0. So they will cancel each other out, leaving us 2/3 times b equal to 1. So the inverse of multiplying is to divide. So I would go ahead and I would divide both sides by 2/3. So 2/3 divided by 2/3 is 1. And 1 divided by 2/3 I will do off to the side. So 1 divided by 2/3 means 1 times the reciprocal, which would be 3 over 2, and 1 is 1 over 1. 1 times 3 is 3, and 1 times 2 is 2. So that's going to give me b equals 3 over 2. The second method when dealing with fractions in an equation, especially an equation that has addition and subtraction in it, is to go ahead and use the distributive property. So if you recall, the distributive property is the one that says when we're taking a factor and multiplying it by a sum or a difference, we distribute it to each term in that sum or difference. So when we're going to use the distributive property to get rid of fractions, the first thing we have to do is look for common denominators. So our denominators are 6, 3, and 4. So if we made a list of those and we went through the multiples of 3, 6, 9, 12, 15, etc., the multiples of 4, 8, 12, 16, etc., 6, 12, 18, 24, etc. What's the one that they all have in common? That's the first one. Well, I see that they all share 12 as a common multiple. That's our common denominator. So the common denominator method means that if I go ahead and I use the distributive property and I multiply everything in this equation by that common denominator, I can get rid of all of my fractions. Okay, so let's do 12 times 5 over 6. So 12, remember, is 12 over 1. So I would do simplifying. 6 divided by 6 is 1. 12 divided by 6 is 2. 2 times 5 is 10. 1 times 1 is 1. And 10 over 1 makes 10. So when I distribute 12 times 5 over 6, that term becomes 10. So now I'm going to go ahead and do the same thing, but I'm going to do it for 12 times 1/3 g. So 12 times 1/3 g. Okay, so 12 and 3 have a common factor of 3. So 12 divided by 3 is 4, and 3 divided by 3 is 1. 4 times 1 is 4, and 1 times 1 is 1, and 4 over 1 is 4. So that's going to give me, and I still have g, sorry, 4g. So this term, when I distribute it, becomes 10 minus 4g. So now I can't forget to distribute to the term that's on the other side of the equal sign, 3/4. So when I do that, I get 12 times 3 over 4. And remember, 12 is 12 over 1. So 12 and 4 have a common factor of 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 3 times 3 is 9. 1 times 1 is 1. 9 over 1 is 9. So when I do 12 times 3 over 4, I get 9. So now my equation is just 10 minus 4g equals 9. Now I'm ready to go ahead and solve it algebraically. So first, I'm going to get rid of 10 because I want to work outside in. So it's positive 10. So to make it a 0, I'm going to subtract 10 from both sides. So 10 take away 10 gives me 0. And 9 take away 10 is negative 1. So that gives me negative 4g equals negative 1. And now I'm going to go ahead and divide both sides by negative 4. So a negative divided by negative makes it a positive. So I'm left with positive 1g. So negative 4 and negative 4 cancel. And negative divided by negative makes it a positive. and it's still a fraction because the 4 is in the denominator, and so I get 1/4. And to check if I got it right, I go back to my original, and I substitute 1/4, and my question is this going to be 3/4 when I'm done? So following order of operations, I would multiply 1/3 times 1/4. So that's 1 times 1 is 1, 3 times 4 is 12. Common denominator, so I'm going to multiply 6 times 2 and 5 times 2, which gives me 10/12 minus 1/12, which is 9/12, which gives me 3/4, which is exactly what I was supposed to get. So that tells me that 1/4 is indeed the correct solution. Now, being able to just solve an equation isn't all that we need to do. We also need to be able to write equations and solve them. So let's look at a timely and contemporary problem. So at present in Tampa, Florida, there are 478 persons infected with COVID-19. Epidemiologists predict that over the next 7 days, this number will increase to 645. What's the average number of persons predicted to be infected daily over this period in Tampa? So right now we have 478. It's going to increase, which means it's going to go up by some mystery number, and it's going to take place 7 days. It's going to happen, and then it's going to eventually get to this. So that means we're trying to figure out the average number, which means it's going to be the same every single day. 2, 3, 4, 5, 6, 7. So we need the same number for all 7 of those days, which means we're looking for a number that we can add the same value to for 7 days. So we need a variable for that daily increase. So I'm going to let it be D. So D is going to be my average daily increase. And so my equation would be 478 plus adding a number 7 times the same number is the same as multiplying. So I'm adding that number 7 times over, and it's going to give me 645. And so now I can go ahead and I can solve it. So I'm going to subtract 478 from both sides. And when I go ahead and do 645 minus 478, I get 167. And then when I go ahead and I divide 167 and 7D both by 7, I get D is not exactly, but approximately 23.9, which means in Tampa that they can expect that the average number of infections would increase by about 23.9 persons per day.